To have a life, you have to be alive. And today I'm going to talk to you a little bit about how you can prove it. That's an interesting proposition. You probably thought you were alive. You probably are if you're watching this. But hey, somebody might make you prove it. So we're also going to talk a little bit about carbon dioxide. Many of you have heard of that. It's a gas in our atmosphere. It's not a very abundant gas, but it's present, far below 1% in air. But it is important to us, and it has a lot of consequences. One of the things that I'm going to talk about today is how we get carbon dioxide, and it's largely from what we call combustion, or the combination of carbon-containing fuels with oxygen. It's oxidation or combustion, and the products of that are water and carbon dioxide. Now there's a lot of water in the air as well, and a lot of carbon dioxide, but there's a lot more oxygen. Air is about 20% oxygen. That's the air that you breathe in. But when you breathe it out, it's only 16% oxygen because your body uses it. Well, what are we doing with that oxygen? Well, think about it. Fuels like coal, petroleum, wood can all be combined with oxygen, and when you do that, you get energy back, like fire and heat, and we can use that to drive turbines and make electricity. We can use it to power our vehicles. And so we use carbon fuels and the reaction with oxygen quite often in our lives. But we also use it in a personal way. Wood is really made up of fibers that are a bunch of small sugar molecules. Now you can't eat wood and it doesn't taste very sweet because your body isn't set up for that, but you can eat sugar. And when you do that and you breathe in oxygen, the combination of sugar and oxygen can result in a combustion process that produces carbon dioxide. So you breathe in 20% oxygen, you breathe out 16, and you breathe out carbon dioxide, which is the product of that reaction with sugar and oxygen. And when you do that, you create energy for your body. Thankfully, you don't catch on fire. But I'm going to prove this to you now that I'm breathing carbon dioxide. So I'm going to need some lime water. Lime. Now, where does that come from? Well, this is called lime water, and it doesn't look like a lime, but its name comes from the chemical that's in here called calcium oxide. Lime is called lime because when you heat up limestone, calcium carbonate, you can make calcium oxide. And then when you put calcium oxide in water, it becomes calcium hydroxide. So blame the geologists for the name. It's called lime water. So this has calcium hydroxide in it, and I'm going to pour some into 2 cups so you can see what's going to happen. One with me breathing into it, and the other one just sitting there. When lime water captures carbon dioxide from my breath, it's going to reform limestone. Now, I already told you that calcium hydroxide is soluble in water, so it's nice and clear. But when it forms limestone, do you think it's going to be soluble? No. Limestone is not soluble. That's why it's a mineral. So watch this. I think you can see the difference. I'm alive. This is calcium carbonate forming in the solution here. And I could do the same thing in this one, of course, because it started out the same way. But I think you see the point. I have carbon dioxide in my breath, and when I breathe it out, it forms the salt, which is insoluble, and proves that I'm alive. Now that was pretty obvious, right? But you never know. I don't know what kind of things you're into, but if you thought I was a robot or a zombie, maybe you'd want me to try this just to be sure. What else could you use it for? Well, you probably already knew about this, but carbon dioxide dissolves in water as well by itself when you don't have lime in it, and it just dissolves in water and forms an acid called carbonic acid. It also creates a lot of fizz in things like soda pop and seltzer water. And so you can enjoy that as the fizz on your tongue. Also, carbon dioxide can be used to put out fires because it's a product of combustion. It doesn't support combustion. So I'm going to show you an experiment you can do at home. I can't do it here because I'm not going to be allowed to light a candle today. But if you have a candle in a jar, you can do this experiment. This is baking soda. You probably have some in your kitchen. And I'm just going to put all this in the bottom, which is what you would do. A couple of tablespoons is plenty, I think. And then I put a candle in here. And I would light that candle in the jar. And you know what happens when you add vinegar to baking soda? You might have seen this before, but acid and baking soda will make carbon dioxide. And as soon as you do that, you have to pretend that this candle is lit. And by the way, you can try this. Light your candle and then pour in some baking soda or some vinegar on the baking soda, and you'll see the fizz at the bottom. And when the carbon dioxide comes up, it'll envelop or wrap itself around the flame, and you'll see what happens. Carbon dioxide is used all the time commercially in fire extinguishers. You see those fire extinguishers hanging on the wall? Well, you can lift those up and pull the trigger, and some of them will shoot out a nice stream of carbon dioxide, which is a gas, right? And so it puts out the fire and it doesn't leave any residue. So it's one of the more popular kinds of fire extinguishers for fires of electrical equipment, which you wouldn't want to have get water on them or some other chemical that puts out the fire. So carbon dioxide is very important for that as well. Finally, oh yes, I wanted to ask you about baking soda. You wondered, what about baking soda? Well, it's got carbon dioxide in it that gets released when the acid is poured on it. It also can release when you heat it. And if you've made cookies before, you probably used some baking soda. Otherwise, those cookies were pretty crispy. The baking soda, during baking, will release carbon dioxide and puff up the cookie so that it tastes nice and soft and moist. So carbon dioxide is useful for what we call leavening or adding air to our baked goods like cakes and cookies. One last thing about carbon dioxide. You know, too much of anything can be bad. And even though carbon dioxide is very helpful, we can overdo it. We're always making carbon dioxide when I breathe, when I bake cookies, but also when I burn fuels. In fact, we do that a lot. Fuels like coal and petroleum, natural gas are used to heat our homes, to power our cars, and generally to make energy. So when we do that, we increase the amount of carbon dioxide in our atmosphere. The more carbon dioxide, the warmer the planet gets. Now this is having some long-term consequences to our climate and our weather and to all of the things that grow and live on this planet. So just a reminder to be conservative in your habits, to not use more than you need, to save energy, and to save some for someone else. Thank you.